Hello, folks. Mic testing one, two, three. Let's get started. So, in this video, I wanted to actually talk about two things. One is zombie processes in Linux, in the Linux operating system, in the Linux kernel, and the other is about fork bomb, which is basically um, a kind of thing where you actually create multiple processes. Let's say, for example, in Linux, I'll show you Linux. So how you continuously create processes in an exponential manner, causing the system to use up all the resources for those processes, dummy processes, kind of like a denial of service attack. So let's get started. Just a minute. So first of all, let's start with what is a zombie process. So I'll show you a zombie process in Linux specifically, though it can be a thing even in say macOS in Unix. So a zombie process, also known as a defunct process, is a Linux in Linux. Okay, is a child process that has completed its execution, but still has an entry in the system's process table. So the process table is a table where you note down all the processes that are running. In this case, this is a process that's completed running, but it's still there. Like it's like a management of all your processes by the system. So it's a table containing all the processes that are currently running or are done running, but they still are part of the table, just simply lying there. They're not using up any resources. So because its parent process, for example, only a child process can become a zombie process because its parent process has not yet retrieved the exit status and has not garbage collected the process, the child process. So as you can see here, I'm saying zombie process in Linux, but zombie processes can also happen in macOS. For example, I am currently on macOS, and this is MacBook Pro 14-inch. This is the Apple M4, not even Intel or AMD, and yeah, I mean it's a Mac OS. It's not Linux. I'll show you that even in macOS, zombie processes are possible, right? So when a child process finishes, so how they occur when a child process finishes doing its work or process, it sends a child signal to its parent process to indicate termination. It then enters the zombie state, retaining only its process ID and exit status in the process table. The process table looks like it has the exit status of the process too. The parent is expected to use a system call like wait or wait PID. These are actually uh, system calls in C programming language, and Linux kernel is specifically written in like C programming language, like most of it is. So Linux, as you can see, one moment is written. Linux is written in which language, and you can actually see that it's primarily written in C programming language with significant portions also in assembly language, assembly code for hardware specific tasks, and increasingly experimental support for Rust for memory safety and all. So C is the core language, assembly for low level bits, and Rust as the modern addition. So from what I remember, Rust is being used for device drivers and stuff. Let me see. Um, Gotta read more, but you can actually check out the Wikipedia also that it's written mostly in C, assembly language, and Rust. So C is the primary language because it was written long back. Rust is a new language, so now I think they're trying to use a bit of that. Cool. So just a minute. Rust in Linux. You can come back to this later. Okay. So wait and wait PID are actually C programming language functions. We'll get to that. And they are system calls for the Linux system to read this status, the exit status, and perform the final cleanup. Like it's kind of like a garbage collection. If you know what is garbage collection in programming language, like in the domain of programming languages, garbage collection means collecting up all the unnecessary resources and cleaning them up, and making space available or resources available for useful things, and make resources available that are being used by unnecessary things or not required things. usually say objects and things like that. So here, so it's in garbage collection. Basically, you do it so that you have, say, enough memory and all that, uh, so that you can reuse memory for storing some of the data. And when garbage collection doesn't happen properly, or there is no garbage collector, and the developer has to do the garbage collection, developers have to code it out. It's possible that they don't do the garbage collection, and hence leaks happen, like memory leak and all. So basically, memory leak is where memory is used up and then it's not cleaned up, and it's just, according to the operating system, it's just lying there for a process, but the process is not using it for any useful thing. It's just there, and allocated, and what do you say, hogged by the process, but not also used by the process. Or it's used by the process, like there are some objects, but it's not being cleaned up. It's just lying there for no purpose, and it's wasting resources. Cool. So here in this case, I mean, I have to think. Can you call it that? Which is process leaks. So zombie processes sound like a process leak to me, similar to memory leak. Um, Process leak in Linux. Let me try to check it out. Memory leak in Linux. Let's check these two things. So what's a memory leak? Occurs when a program continuously allocates memory, dynamic memory, but fails to free it after use. Right. Just a minute. Something. Stay in the call. Okay, so eventually depleting available RAM and causing performance issues and all, or the system crashes, right? So you can actually find out how memory leaks happen by using different tools. So looks like there is something called Valgrind and all. Anyways, and there are profiling, like these libraries are called profiling libraries, or tools are called profiling tools. They help you profile, that is, find out the usage of CPU RAM and understand which parts of the program and which parts of the program execution is taking up too much CPU, too much RAM. So yeah, you can check it out. So different languages have different tools available out there. So, what's a process leak? I mean, I just guessed that it might be a thing because memory leak is a thing where memory is not freed after using up. Similarly, a child process, if it's not freed from the process table after using up, after running the process, then is it called a process leak? So, most commonly refers to a memory leak within a specific program, or as frequently an accumulation of zombie processes. Yeah. So kind of, it's not exactly a very standard term, I guess. So you can simply call it in a slang, but there's no specific official term, I guess, for it. So detail per process memory mapping analysis, interesting. So slash proc is the place where processes are stored. It's a proc is actually the slash proc is not a real file system. It's actually a proc file system, I think. Procfs. Um, in Linux. It's a Linux thing. It's a virtual file system. It's not a real files. It's just the interface is files. Yes. So I'll show you that. So zombie processes, they occur like this, where you run a child process, it finishes running, it has the exit status in the process table, but the parent process does not read the exit status and does not clean up the child process, right? Basically garbage collect or reap the child process. A zombie process occurs when the parent process fails to call wait or handle the sick child signal properly, leaving the dead child's entry in the table indefinitely. So system impact, basically, what is the impact or what is the problem because of this? Zombie processes, if a lot of them accumulate, so there is actually a max number on how many processes the Linux kernel can handle. I think the value of this is 2 power 64, which is around 4 million. Oh, it's actually not 2 power 64 then. I think it's lesser. Maybe I got the number wrong. 2 power 32. Is that 4 million? Yeah, that is 4. No, that's 4 billion. Okay. I think I got the numbers wrong. 30. Interesting. So this is 4 billion. I remember it to be some 4 million, some number. Let me come to that. So, zombie processes do not consume significant system resources like CPU or memory, but they do. They only occupy an entry in the process table. They do occupy a space in the process table, and you'll also find that this process shows up in the PS command, PSOX, and all. And it also shows up in the slash proc virtual file system in the Linux system. So, however, if many accumulate the zombie processes, they can exhaust the limited number of available PIDs, process IDs, preventing new processes from being created. So, you can't create new processes and potentially causing system instability or a denial of service attack condition, right? So, identification and management, you can identify zombie processes using various Linux commands by looking for the status code Z, which is short for zombie. There is also a symbol called Z plus, I think. One is for background and Z plus is, I think, for foreground. And the word defunct in the output. So PSOX lists all running processes. Look for Z in the stat, which is status column, or the defunct in the command column. So top or htop, these real-time monitoring tools display the number of zombie processes in the summary section and mark individual processes with Z in the state column. Filtered PS command. So these are the things. So you cannot kill a zombie process, by the way. The parent has to do it directly because it is already dead. So it's a zombie process. So the process is done running. It's just part of the process table. So the only way to remove it is to deal with its parent process. Either kill the parent process. When you do that, basically when the parent process dies, the child processes of the parent process are given to the init process, which is the topmost root process, and the init process will then clean up all these child processes, which are zombie processes. So that's what is being mentioned here. If like signaling doesn't, like, there's something called signal the parent, where you send a signal, send a sig child signal to the parent process using kill -s sig child parent PID. So if the parent process is programmed in such a way that it handles the sick child, where it actually cleans up all its zombie processes, great, right? So well-written program, parent program should then reap its zombie children process. And if signaling doesn't work, terminating the parent process will cause its orphaned children to be adopted by the init process PID1. The init process automatically and periodically reaps its adopted zombies. Use kill parent ID, sends sig term, or kill -9 parent process ID, which is sig kill if necessary. So let's actually try creating such a zombie process, right? So I actually have an example for a zombie process. Um, Let me give you. So first of all, let me start with the process example in general, how it looks like, right? So here you can actually see. So this is a C programming language code, right? I'll initially run it in my Mac OS to simply show it, and then next I'll run it in Linux also, right? So here you can actually see that I have stdio.h for input output stuff for the C programming language, the header file, the library, and standard library for standard lib stuff, and then types for getting some types. For example, these I think come from, okay, these come from stdlib, and this comes from types, right? And wait PID comes from wait.h, and I think p error comes from stdio. Okay, let me see if I comment this out. Nothing goes wrong, is it? I wonder why uni std is required. Anyways, this is some code that I got from AI, but maybe I should try checking out what this even has. Does it have exit stuff, p error, or printf? Nope. I wonder what else it has. Anyways, I will probably try out removing these, but this one, I think it should show that PID is not working. Doesn't show that. Let me actually run this thing. So process example, sorry, zombie process. So first we look at zombie process. Later we'll be looking at fork bomb also. So I'll start with the process example.c, right? Uh, Let me just do GCC process example. Let's see hyphen o process example, right? So if you run this, let me try this out. Okay, so this does work, right? Interestingly, even when sys wait.h was not part of it, I'll make it part of it for now. And so if I do GCC, and GCC is the GNU C compiler, G++ is the GNU C++ compiler. So I'm going to be using the C compiler, though you can use the C++ compiler also. And I've written C programs, so no C in C out or any objects or classes, basically the features of C++. So here you can actually see that it created, so this is the parent process, which is 74319. It created a child process, and the child process is this. It's running ls-l command. So basically how this works is you call fork. Fork is supposed to actually create another program of the same kind, of the same fingerprint, or what do you say, blueprint, or gene, right, or biology of the process. The whole process as it is forked, and then from there it starts running, right? So for example, if I do a fork here, uh, the parent will be running here and the child will also be running here. The PID though for the the child will be 0, right? And to get the PID of the child, you need to just call get PID, and the PID for in the parent will be actually the process ID of the child, right? To get the process ID of the parent, you need to actually do get PID, right? So the parent will be running here. This block is executed by the parent process, as you can see here, and this block is executed by the child process, as you can see here. So 1 minute. Okay, so now basically now what we do here is I'm going to actually show you that I mean if the fork fails, the PID is -1 and it says fork failed. Okay, and you can actually see that once the fork is done, we actually replace the program to run. Initially, the child process will have this program as the program to run, and when you so what you do is you replace the child process's image with a new program, and that's what you do here by doing exec lp. So p is short for path, and l, let me try to recall, I think it's for a list of arguments. Let me show it to you. 1 moment. Okay, wait. Yeah, here. So exec lp. So you can actually see here what it means. So 1 minute. Exec lp full form, right? So the full form, basically the L is for list. So indicates that the command line arguments are passed as a variable length, comma separated list of pointers, which is what is this. So currently we are passing null, right? And there is also arguments list. This is the arguments. Um, so you can actually pass the arguments as a variable length thing, but we haven't done it that way though. We actually passed it like this. I think actually this is a variable length. Not sure. Got to check more, but this is a pointer. Yes, variable length. Yes. I'm wondering why this null was passed in here, but these two are, yes, the arguments, or more like this is the argument. This is to tell which is the program, and basically ls-l is being run here, right? And basically it indicates that the system will use the path environment variable to search for the executable, which is this ls. That's why the p path, and p error is just to give you errors. So You can check out. There might be thousands or millions of ways to do this. I'm just using a very simple way. I got this program written using an AI, and I started tweaking it to understand what is going on. I need to go through more into this because, for example, there are other exec commands like or exec functions like execv, execve, execpp, and all that. And there's more, right? So now, and the parent process basically just says wait for the process ID, which is the child process ID PID, and it gets the status. And I think the last one, not sure what this is supposed to mean. This is all macOS stuff. In macOS, it's showing what is the like library, so it's a Darwin thing. In Linux, I think it'll be a bit different, and you can actually see that there is also a definition of sorts over here. So you get the status, and you say child process exited with status this, child process terminated abnormally, right? So I'm not sure what this shows exactly, but here you can see that it says with zero and all that. So it's trying to understand what is the process exit status. And finally, you say one, like zero, which is zero errors of sorts. That's how I remember it, to say that it exited with successful status. Like exit status is successful, so zero. If it's a failure, it's like this. Like for example, 1, -1, 127, whatever you want. Each code has its own meaning, standard definition, but you can use any code you want, custom codes and all. So here I'm running this and it's working out. So next I'm going to actually use a Linux system and run this and show it to you. So I'm going to be using this environment called Xemius. So Xemius is actually a good and popular website, and they have a lab now of sorts which has an ability to run playgrounds, and it has like a free tier. So 1 hour of playground every day, right? So you can work with it for 1 hour every day and go ahead and play with things. So here I'm using an Ubuntu machine, and I'm going to be actually running this. So since this does not have GCC, I'm going to install GCC. So 1 minute, app installed build essential. Let me just get this done. I need to write this down somewhere. Debian or apt commands. This apt update, right? So I'll need to update first. Oops, not this. Yeah, of course, apt is not here. So okay, oh yeah, it's basically sudo apt because by default it runs in a non-root thing. So sudo apt, and let's get started with build essential. And just a minute. Okay. Something's wrong. 1 minute. Let me update sudo. Okay. I'm wondering why I can't close this. Interesting. Okay, anyways, for some reason I'm not able to close it. Anyways, so here what I'm going to do is I'm going to create a folder called Linux, and I'm going to call zombie process, similar to how I have it here, and then I'm going to actually put this process example over there. So process example, just copy this and say process example.c is going to use it here, right? So explain, interesting. Okay, it's for GitHub Copilot. Anyways, so here I'm gonna just go ahead and run this. Right now I should have GCC. I didn't install yet. This, yeah. Once this is installed, I think I should have GCC. Yeah, I wish this was gone. I'm gonna ensure this is gone in the next one. It's gonna take some time, so we have quite some time. Let's see. Interesting. Like click this and then close it. It goes to the other one. Anyways, 34%, 40%, 42%. Oh, where's my face? It's here. 69%, 74%, 76, 83%. And they are good to go. Yeah, there's a lot. I'm just cleaning up. Okay, cool. Now you should have GCC. Okay, so now I'm just gonna say GCC. I'm just gonna go inside Linux and zombie process, and then say GCC process. I should know process, and then just run it. Process example, right? So it runs it. And if you try out the ps command, you should be able to see what and all processes you are running. If you write psaux, you should be able to see even the root. It's running a lot of stuff. So yeah, and I mean this is part of the whole the playground. So what are they running? For example, code server and stuff like that. So this is part of your user to run the code server for this, I think, and then also it has a lot of root related stuff for say. Okay, if you can see here, it's the root providing the like SSH server for this privileged thing, and then this is your terminal. Cool. So now I'm gonna actually show you just a minute. I'm actually gonna reload this for a moment just so that I can actually close this. Let me see if I can close it now. Yeah, okay. This doesn't show up. Good. Cool. Okay, so here what I'm gonna do next is I'm gonna actually try out zombie process. Okay, so I'm going to have a zombie process example where basically I'll create a child process, right? And so basically I do a fork and I run some program over here, for example, say ls. I don't really have to run anything, but let's just say I run ls, right? And then if it doesn't run, it fails, right? And then in the parent side, I say parent process is this, and then I sleep for 100 seconds. So what happens here is I don't wait. If you can see here, I have commented out all the lines which says wait and show the process like child process status code and all. I don't wait, right? So I just sleep, and while I sleep for like while the parent process sleeps for like 100 seconds, which means the parent process is still running, but the child process is done running and it's dead, right? But its exit status code is not read by the parent process, and and the child process itself is not removed from the Linux process table by the parent process, and the parent process is still running. So until and unless the parent process is killed, the child process, the dead child process, which is the zombie process, will remain in the process table. When the parent process dies or it's killed by someone else from the outside, then the init process adopts the child process and it kills the, I mean, it does not kill, it reaps or cleans up the child process from the process table, right? So let's see that happening. By the way, this also happens in macOS. So I can show that to you. So GCC You say zombie process. By the way, we also have other examples called you know many zombie processes example, and then infinite zombie processes, also another zombie process and all that, right? So where you run nothing. Cool. So zombie process example dot c and hyphen o zombie process example, right? So you run this and you see that the ls command runs, and in the another nearby terminal you can actually run ps, and you can actually see defunct over here, and in psaux you can actually see that there is a zombie process. 1 minute. Okay, so you can actually see this z plus, or you can actually look for defunct, and you'll actually see that this is z plus, right? I wonder what is r plus. Basically it's the grep that just ran, and it shows up here. So this will be there for some time till the current process is dead. If you can see here, um, let me see if I can actually use this to run this. So you can see here that I'm looking for the defunct process, right? And you can see that this z plus is still there, right? Let me just this is still there. Let me just close this and it should be gone. As you can see, it's gone, right? So there is a init process, I believe. Let me see. Init is there. Server init. Okay, I can't find any init. I'm guessing in Unix there must be something. But if you run this, you will notice that there is a defunct and grep z, right? And when you keep doing this, um, you'll realize that uh, the process just exists, and once you kill it, right? Let's say I just take it out over here and keep it here. Let's say keep it here and keep this on the left, right? And I do this like I think you can actually have a infinite for loop, right? Where you do bash infinite while loop. I think there is a for or while. I think while and then true and then do done. Cool. So I'm just gonna go ahead and do while true and then do sleep done. I think that's wrong. I need to remove this. Okay, sleep one. Okay, it's gonna sleep, and I can also say echo something. Echo blah. Yeah, every once again it'll just do blah. Cool. So now what I'm gonna do is I'm gonna actually run the command that we ran, which is psaux this, right? Um, okay. So do psaux and psaux grep defunct grep z, right? So as of now, there's nothing showing up. So I'm going to run this. So now when I run this, it shows up, right? Once I kill this, let me actually put something over here. Let's say echo in or date, right? So it gives the time, and you can actually see how it goes. Can I give date percentage plus t f no nanosecond hyphen I ns? Okay, let me just do hyphen ins over here, hyphen ins, right? So now I can actually see this here, and when I stop it here, it stops. The moment I stopped it, it stopped over here. As you can see, just run it. The moment I stop, it stops here, right? So now this is in Unix, by the way, right? Now let's do the same thing in Linux, right? So can I have yeah, I'll have another terminal over here. I will actually do this. I want to do this. I'll just say commands over here, not app commands, commands. So I'll just say this, right? So just gonna use this here. I'm gonna put the zombie process example, right? Just gonna copy it and put here. Process example.c. Okay. Oops. I think I should restart this. Restart this. Okay. Cool. I think you okay. When you try, oops. I think I closed up something. Just a minute. Labs. Yes. Uh-huh. Okay. Oh yeah. I basically closed it up. So I'm sorry. Um. Run this. So in the ID, actually, it will ask if you want to exit. That time, I think the terminals, the connection close. Uh, okay, I didn't realize that this is what happens. When you do this, I think the terminal connections close. Yeah, can you see here? Cool. So I will not do that anyways. So I have the zombie process over here now. So interesting. I'll come back to this later. This is a root file system something. Okay, so zombie process example. Okay. So now I'm just gonna go ahead and say we have the commands, right? Let's just say gcc process example.c hyphen o process example, right? Similar to this, I have zombie process example, uh, right? Cool. So I'm just gonna go ahead and do this. What's this file directory? Oh yeah, I need to get into Linux. Okay, cool. And then I basically run this, right? Oops. So I just run this now, right? So the zombie process is running now. Let me actually show you that this is there. So it's here, and you can see it's Z plus. So Z plus is supposed to mean that it's a background, like foreground. It's running in the foreground. The child process ran in the foreground. If it's in the background, then you won't see Z plus. Instead, you'll see Z. You can actually find out the difference between the Z and the Z plus process in Linux, right? So here you can see that Z plus that appears in the stat column. So meaning it signifies that the process belongs to the foreground process group of its controlling terminal. Just a minute. So therefore Z plus means the process is a zombie process that also happens to be in the foreground process group at the time the PS command was run. Here it's basically in the background, I think. So but still has completed its execution, but still has an entry. The problem z versus z plus. So indicating how process is being managed, particularly regarding its termination and interaction with its parent process, zombie or defunct. Visibility in the output of command like ps, it is typically shown with the status of z or the defunct. So not in the foreground process group of the terminal, in the foreground process group of the terminal. So that's why z plus. So now this is done actually. Let me run it again, and this time I'll actually do a I'll run this continuously, right? So when I stop it here, you should see that this is done. The moment I stop it, it's done, right? Currently, none of them is running. Just let's just say I do this, it's continuously running, and I stop it, it stops here also, right? So we have created a zombie process now, right? We know how to create one zombie process. Let's create multiple zombie processes. Before that, I want to show you a zombie process where no other new command is being run. So this is that zombie process, right? And when we create many, we'll create say some echo or something like that. We'll put this in, right? Just to simply run something, though we don't have to. And then we'll create infinite zombie processes also. So let's start with this another zombie process. Let me just create a new file here. Oops. I think this another zombie process. Let's see. I think that's the one. Yeah. Cool. Let me create a command for this. Um, there's no example here. And then another zombie process. Cool. Let me just run this. Right. And then I'll just run this. So it's done. Run ps hogs grep in another terminal to see the term zombie. So I mean the parent process is still running. So we have a sleep 20 here. So after 20 seconds it should be done. It's done now. So here if you just run it now, you should be able to see this. Once it dies, you should be able to see that this stops. The moment this goes off, this stops actually. It's 20 seconds, so that's a lot. Okay, so it stopped actually, right? So we can even actually show something like you know I don't know, maybe running something like exec this, right? But anyways, in the parent process to just print what is the time when it just died. um Anyways, so now I'm going to actually create many zombie processes with just an echo example. Okay, so zombie process example, we have done process example, zombie process example, and another zombie process. So we'll just do many zombie processes and then finally infinite, right? So in the commands I'll just do uh, this. So here we have many zombie processes. I'll make it as infinite zombie processes. Cool. Okay, many zombie processes example. Sorry, this is example. Okay, cool. So now I'm gonna just go ahead and have the commands and mini zombie process example. So I'll just copy this. So here we are just running echo hyphen n, and then we stop. Right? That's all. We don't do anything. And here we don't wait, but of course, like here, as you can see, we actually run a sleep over here. This sleep will run in the child also, is it? Let me recall. No, it won't run in the child because we have actually ensured that the child runs this and then stops. It exits, right? It exits with whatever is the exit status of this, and if there's a failure, it'll exit with this failure. So only the parent will sleep, but you can also put this sleep here, I think. So for now, I'm just gonna go ahead and make a file here. Um, let's call it instrument. Oops. Okay. New file. New file this. And oops. Copy this. Right. And here, now we can actually say something like many zombie processes example. Right. And remember, we are actually putting this in a loop. So I forgot to mention that we are putting this in a loop now. That's the difference. Putting this in a loop, and we actually run 5 of them. And echo hyphen n basically gives nothing. So if you can see here, in Linux at least, in macOS I think it's a bit different. Echo hyphen n basically gives you like nothing. If you say just echo, it puts a new line. Um, okay, even in macOS it's the same. Hyphen n removes the new line, and if you don't have a hyphen n, it gives you a new line. So we're going to run that 5 times, right? So we're going to fork it and run it 5 times, and like you know, all of them will be replaced by this. Uh, the parent process alone, like if we put a sleep here, um, it will wait in the loop itself to create another child process. So I didn't put a sleep there, right? So I can't recall what I was thinking, but looks like I thought clearly and did this. Give me a moment. Hang on. Hello, folks. I'm back. Cool. So, looks like I've thought about it very clearly, and hence the sleep over here instead of within the loop. Because if I put it within the loop, for every iteration, it will wait for 100 seconds and then it will do the iterations. So this sleep actually will ensure that it sleeps for this much seconds, right? So we continuously run this echo, echo, echo 5 times, and then we sleep in the parent process, right? So let's look at how this goes on. So this we can actually even run in my macOS. Let me show how that looks like. Okay, so it's running, and I can actually use this to check it out, right? So as you can see, there is 1, 2, 3, 4, 5, 5 of them, right? So if I actually do this, so you can actually see that it just keeps going on. If I stop it, it just stops here, right? So if I stop the parent process, it gets reaped. The init process or the top level process takes command and adopts the child processes of the orphaned child processes of the parent process, which just died, and then the child processes are cleaned up. It's uh, the process is cleaned up and reaped from the process table. So now let's look at the same thing over here. Let me try to do this, and so it's running, right? Now I put echo hyphen n because if I put echo, there'll be 5 lines. Later, when I make many into infinite processes, there'll be so infinite new lines coming up. So I didn't want to do that, and that's why I just did it this way, so that there are no new lines for every process getting created, child process getting created. So in infinite, I basically do like there's no 5, there's nothing over here, right? So now it's running and 100 seconds sleep. So I'm just gonna go ahead and do this. So you can actually see there are like echo, 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 and like 5 of them. And if I actually do this, you can actually see this happening. And then once you stop the parent process, it's all clear, right? So yeah. So now let's go ahead and do infinite processes, right? So I need to put this over here. I think get ignored. Yeah. Cool. So I think I didn't ignore the infinite process example also. I'll do this. Yeah. Okay. So I'll run this. I don't want to run the infinite process example in my local because it will kill my machine and I won't be able to record this properly. So I'll just run it over here alone. Before I do it, the command, like the file is not created. So let me just create the file. Close it. New file. Call it as this. Let's see. And create it. Cool. Now let's see that created. And I'm just going to go ahead and run infinite processes, right? And there won't be any sleep also. Let me also do this, right? There are nothing coming up here. Now this thing will crash, right? So you'll actually see so many processes getting created, right? So now at some point it will say that resource unavailable, right? Resource temporarily unavailable. Process created is like how many processes got created. I put that down so that you can actually understand how many processes were created. So for example, here, if you look at the thing, I finish when you are not able to fork. I actually say how many processes were created and then I stop. Basically, the parent stops running, right? And that's when these stop. So basically, you actually had 10,500 processes and then it just died. So how do you know that what are the maximum number of processes you can create in a Linux machine? You can actually check out using ulimit -a and you look at max user processes. It's 15,939 over here, right? But for some reason, I think you can just run 10,508 something. And you can also check out at isolated process level how much can be created. So if you look at so /proc is your virtual file system for showing all the process information. So if you see mount, let's close this for now. If you look at mount, you'll actually find out. Let me show you. Grep proc. You'll actually find out that there is proc, right? On /proc, which is the type is called proc file system, right? And you'll also notice there is sys file system, right? And you'll also find a C group file system, right? Which is C group V2, by the way. There is V1 also, which is an older version. So here, if you actually do ls proc and then you go into in proc. There is sys, by the way. You go into kernel. You'll find out the max PID you can have. Oh my god, sorry. PID max. So here you can see the PID max, which is according to the kernel, the uh, maximum number of process IDs that you can have is 4 million, 4194304, as you can see here. Um, but for some reason, I think they clearly ensure that that doesn't happen. And you can find similar stuff in the C groups also, I think. Let me see. So if you look at LS, FS, C group, you'll find C group procs. Let me see what type of file this is. This is an empty file, okay? So these are the procs it shows. The C group, and let me look for config debug system slice user slice. Okay, user dot slice PID is max. So oops. So here you can actually see the number of processes IDs. It says max. Okay, that's interesting. C groups procs. PID is max is max. I'm not sure what it's supposed to mean. Um, PID is max. Yeah, cool. So looks like it's defined over here that it's 10,520. So I think Laborant is this user 1001. To find out all the users and their user ID, let me check it out. List Linux users, right? So I mean, if you type on who, apparently it should give you who am I, should give you the name. Yes, who gives you this? And awk-f etc password. Okay, so cat etc password. So here you should be able to see that Laborand is basically the 1001. The user ID is 1001. Find my user ID in Linux. So you just say ID, I think, and that's it. Good. Just say ID. So that's it. So your user ID is 1001 and your group ID is also 1001, part of the Labyrinth group. ID help. So you should be able to see hyphen user or hyphen u 1001. These null characters, not white space. So real ID instead of the effective ID with hyphen. Okay, so hyphen real in default format. Okay. Hyphen UGG. I don't know what. No. Oh, okay. So context only the security context. I'm not sure what this is supposed to mean. The real user, the real ID, name instead of a number, and all the group IDs. Then only the security context of the process. Okay. Context works only on SE Linux enabled. Okay. Um. Okay. Cool. So I think hyphen A is ignored. Anyway, so now you know how it looks like and why this is happening. Like, where to look for when you're looking for the maximum count of things, right? Let me just put that in here. So you're looking at slash proc, and you're looking at mount grep proc and sys fs and C group, right? And Yeah, sysfs. Yep. And also looking at ls slash proc slash sys slash kernel, right? And here you have the PID max. And also looking at C group. I think C group is in sysfs C group. Okay, so sysfs, 1 minute. Sysfs is in slash sys. Okay. Uh-huh. And then you have C group, and here you can look for, oops, let me just say this, not this, and then look at system slice and all that. Um, System slice, and here you can look at the different other stuff, PIDs max for this also. It's just max, which is the actual complete max, I guess. SSH service, PIDs max is 4781. For SSH socket, it's 4781 and whatnot, right? So, oops, yeah, and so you can basically look at all the different PIDs.max. Maybe you can do a PIDs.max, no such file or directory. Recursively find it. So I want to recursively find this path in the expression. Okay, dot, and then PIDs.max. Cool. It's not here. I am looking for it in slash sys slash fs. Okay. No such file or directory. Okay. Interesting. Find C group. Um, find a file named. Find a file in Linux. Find starting directory options expressions. Oh, I have to put it in double quotes. Okay. Oops. Oh, I have to say hyphen name, not simply directly put it. Okay. Hyphen name and then. Okay. Okay, so I found out all of them, right? So you can look for this here. Yeah. Um, Basically, this is what you're looking for. If you want, you can put it as this also. It's all the same, I think. Um, yeah. Cool. So, and then you can actually do cat xargs cat, and you should be able to see the values for these, right? Xargs cat. Yep. Cool. So that is for your infinite processes. So I think we've done all of them now. Um, we've looked at all of them, and we have 18 more minutes, right? Cool. So now the next thing I wanted to talk about is folk bomb. So 1 minute folk stat. Okay. So search. I actually tried out multiple things and then found out only some of the stuff that works. Okay, so I'll probably put this in the commands of this commands.md, and here also I can put it sudo apt install folkstat. Yeah. Folkstat basically gives you um oh sorry apt install. The spelling was wrong, and I have to use sudo. So did I put sudo here? Yes. So when you have folkstat, need to run with root access. Okay, you can basically see what and all new processes are being run. So as you can see here, it's showing different, like PS is being run to check what and all root processes are there, I guess, right? I remember using forkstat just to simply look at what is running. Just a minute. So that's me searching for it. This was long back I was doing it. So sudo forkstat, and then okay, cool. So sudo su maybe forkstat. Yeah, it's basically running some stuff over here. Let me see if I can actually run only. Uh, just a minute. Stay in the call. Okay, folkstat help. So use task command field for process name, run duration, select which events to monitor, equivalent to -e all. Show extra process information equivalent to, okay, run quietly and enable -s. Okay. So it's running quietly. If I do ps ls, does it show up? Nope. I want to be able to actually look at only the files, I mean, only the processes run by this user. And I'm trying to use folkstat for that. Let me just get rid of this and say sudo folkstat and look at what it says: time, event, PID, info, duration, process. Okay. So here, what I'll do is I'll run this. Yes, help task command field for process name, strip of directory path for process name, specify run duration. I think you can mention which events to look for. Folkstat, Nux, fork, core. Okay. So if I say -e fork, okay, this is a fork event. Yeah, looks like there are going to be a lot of them. Anyways, let me just get rid of the root stuff maybe, or let this run. But I'm going to run something called as a fork bomb. So fork bomb, I'll show you what is fork bomb. So it's a thing where you basically try to affect the system by running too many processes in an exponential manner. And basically what happens is you run one process, which in turn runs two processes, which in turn runs four processes, and so on. It, like, the number of processes like double, right, exponentially. And this causes kind of like a denial of service attack, because you're trying to run too many processes and it's using up the system resources. For example, in this case we'll be using a lot of CPU, not much of the RAM. So if you look for fork bomb Linux, a fork bomb is a denial of service attack in Linux and Unix based systems that rapidly and recursively creates new processes until and all system resources are consumed, causing the system to become unresponsive or crash. Right. So this is an example of a fork bomb. It's a bash thing. So the core of a fork bomb relies on the fork system call. So that's why the name called fork bomb. You're bombing the thing using fork system calls, many of them, and trying to create multiple processes, which creates an identical child process of the parent process. A fork bomb implementation places this call with an infinite loop. It's like this keeps going on and causing an exponential growth in the number of processes. Most well-known example is a single line of bash script, which is this. It's very obfuscated or like very weird. It looks very weird because they've used very weird names. Because here the colon is actually a name. Do not run this command on any system you're not prepared to crash or force reboot. Right. So in my playground, I can actually run this, right? And I'm gonna actually stop this and let's say open up one more terminal here, right? I'll run sudo forkstat, right? And it's gonna look at all the things. So here, I'm just gonna run this, right? Weird. When I copied this, I thought I copied it correctly. Okay. So let me just run this, right? And this should create a lot of child processes, as you can see here on the right. And at some point, this is going to actually kill the system. So you should not be able to even access any terminals of sorts. And if you try, well, you will fail. If you try to just run ls, the whole system will be down basically for some time. So the only way to get out of this is by killing the system. So the system is dead. Even your ID will not run. Let's just like you can actually see that this is like loading over here, this blue symbol, right? Like for example, let's say I try to open this up, I can't open it, right? Let me close these, right? And let me close these also. Let me start out a new terminal, but even this will not work because it's continuously running a lot of terminals, like a lot of processes. Let me destroy this, right? So now that I've destroyed it, you should see that it gets destroyed in some time. Yeah, it's gone. So go to dashboard. So no active playgrounds are running. Let me start running this again and let me try to explain what is going on here. Just a minute. Okay, so basically what's happening over here is 1 minute. Bash, and a better way to do this would be to run this, right? So basically what's happening here is what does this do and how does it cause so many processes to get created, right? So if you try to look for fork bomb, you will understand that this is a very popular one, most well-known example, and it's a single line bash script. And here the colon refers to a name of a function. You're just creating a function named colon, right? So it's the name of a function. It's a valid function name in bash. You can have any name, but for obscurity, I think they've just done this. It's common from its brevity, right? You can, I don't know, can you use underscore? I don't know. Maybe you can. So let me actually show you. Can you just use underscore? Nope. Maybe just say echo. Uh, echo. Yeah. So like you can just define that underscore is blah, right? And you can use that to be the thing, right? For example, here you can use underscore, right? So the function name is underscore here, and here the function name is colon, and then you call colon basically without uh, curly braces. You can call them with curly braces also, and it should still work. Um, okay, it doesn't. I think you just have to use this. But if it has some, mm, let me see, bash function with arguments. So you say function name, and then you use $1, $2, and all that. Okay. So you just can't. Okay, so there are no braces, right? So you just use it as it is. So I guess you just can't use this. I'm sorry that I used this over here. I think this cannot be done. I think, can this be done? I'm not sure. Let me check. Let me call something called as bomb, and let me call this. Let me call bomb. It says blah. Can I define it like this? Hmm. Yeah, that doesn't work that way. So then this is wrong. Like, you just can't put braces over here. Um, you can just, it's the same. Like, you can just do this. That's all, right? So 1 minute. I need to actually fix some of the things. Anyways, I'll come back to this. But basically, what you're trying to do is here you just say bomb, and then you call bomb. Bomb internally calls bomb again in a recursive way, and then you pipe the output of the bomb function to again bomb, and this whole thing runs in the background because you put ampersand. And this is the function definition. And the first call is this. First call leads to two other calls, and then every call leads to two other calls, and so on. Since the first call leads to two calls, and again those two calls each will lead to two calls, totally four again. So four will become eight, and so on. So basically, if you look at it here, you'll realize that that's what has been explained here. So braces, like the like not curly braces, the parenthesis denotes that the function is with no parameters, and even if it has parameters, you don't say anything in between. You just say $1 inside the function definition, and then the braces is for the opening and closing of the function. So it encloses the function in a thing, the function block, and you just call the function recursively again and pipe its output to another call of the function colon or bomb, and it runs in the background. So everything is in the background. The parent process doesn't wait for the child process to finish, right? So you just run it in the background, and you're done. So allowing for rapid parallel growth. So command operator. So this is it's not operator, sorry, command separator. So this is just to stop like the function definition, like finish the function definition, and then call the first call of the function. So it's a self-replicating process, quickly depletes available resources such as CPU time, memory, and entries in the operating system's process table. PID limits, like it creates multiple processes, right, exponentially. So the number of process IDs, there is a max limit to it. So that will be exhausted, and CPU will be exhausted. I'm not sure how memory is exhausted here. Something to check out, leading to a system freeze or kernel panic. So this is also called as, I think, rabbit something. Fogbomb. Forgot the. I think it's called rabbit virus. Yeah. So because of how it actually proliferates or creates many processes, the way how rabbits reproduce, many rabbits. So general security, I think you basically just stop the number of processes, like too many processes getting created by a user. So limit the maximum number of processes a single user can create. That's the best thing, because in a fork bomb you're trying to create too many processes. So you just say that you can only create 10 processes, 20 processes, and the amount of resources that they can use, the CPU, RAM, memory. and also the disk also, right? How much they can use. For a current session, you can use the ulimit command. Permanent limit, you can define the permanent limit in the security in the limits conf file. And general security, enforcing general security best practices and preventing untrusted software from running with administrative, that is root privileges, can block most fork bomb attack scenarios, right? So here, let me actually show you. So I showed you fork start, right? How can you stop this from happening? Just a minute. So let's look at this file, hard nproc 500, right? So cat. So I'll just say vi. So I'll just say laborant and say hard and then say nproc and then say 10. I think I can't save this because I didn't open it as a root. Damn it, I'm not able to close it also. How do I close this? Damn it. Anyways, let me just go ahead and do sudo vim and let me just say laborant hard nproc and let's just say 5 processes. So here you can actually see that there is this, right? Ulimit hyphen a should it currently tells me that it's 1500 and sorry 15,939. Um, so but then if I actually try to do something like maybe relogin and ulimit hyphen a, interesting. If I say 5 now, then a, interesting. Ulimit hyphen u 300. Okay, so the playground is dead now because I can't use more than 1 hour. So let me go ahead and use my other playground that I have. So I have a playground here. Cool. So let's get started here. So what I do is ulimit hyphen u 5, and then you see that only 5 can be created. Now, if you try to create, say, even the zombie processes or anything, it should give you an error. So let's just say I create the infinite zombie process example. Um, so process procs, not C. Let me just do that. So let's just say GCC procs. Okay, it says resource temporarily unavailable. Okay, so basically I can't run more than 5 processes according to this. Let me just make it as 100. Sudo. Okay. Might have to reload this. Ulimit hyphen a. Here the max processes I have is 32,041. Okay. I'll make it as just 100. right? So if I have a 100 limit, now if I create a new terminal, what's my limit? U limit hyphen u is this. Okay, cool. For the current session, I've actually created this. So let me start off by using this current session, and I'll just say gcc procs hyphen o procs sudo apt update sudo apt install build essential so if you have now gcc you have it. So if you just run procs, it stops at 47. So it created a lot of them, right? And then it stops at 47. So it's just u limit hyphen a. So if I run it again, it should just stop at 45. Cool. So now I'm gonna actually do this one thing. 1 minute. Sudo apt update install folkstat, then folkstat sudo folkstat. Cool. So I'm gonna actually just do one thing where I'm gonna try to see what and all zombie processes are running, right? So this is just gonna go ahead and just create it. So it immediately created and then it died. Okay. After 45 of them. So for some reason it didn't even show up here even for a moment. It just got killed really fast. So if I actually say ulimit hyphen u is 1000 or even 10,000 sudo okay, so ulimit hyphen a is 100. Can I do 50? Can I do 100? It does not allow me to increase it. Okay, makes sense. So let me just go ahead and close this. Okay, it already got killed. Let me close this. So basically what it starts saying is resource not available, right? Ulimit hyphen a, it's 32,041 here. So if I look at the max for all of them, I think each max is something. So I think if I run procs now, um, you should see that a lot of processes get created, and at some point it should say resource temporarily unavailable because that was the maximum number of processes you could create, right? I wonder how this is different, like where you create zombie processes, but then yeah, these processes are dead though. Immediately they finish, so they're dead. In the case of folk bomb, you just keep creating them and they're not dead; they're still alive. That's the main problem. So here you can actually see that the thing is 32,000 something, but 21,135 is the limit you have. So I'm guessing it's coming from this 21,147. So probably from the user slice. Just let me get it. It must be this one because this one would probably be max. Yeah, this is max. So this is 21,147. So here you can see these many processes got created, and then finally folks said this was temporarily unavailable, and it's referring to the process ID as a resource to say that it cannot create more process IDs. Right? So now let's try out a folk bomb, and one moment. For a folk bomb, I'm gonna try to run like install folkstat. Right? And before I do the folk bomb, I'm gonna actually reduce the number of processes that this can run. U limit hyphen is 32,000, right? I'll make it as 200, right? So you can actually see it's 200 now. And let me do a fork bomb. I'll use this, which is more clearer, right? And I'm going to use forkstat to check out how many processes get created. So here you can actually see it says at some point resource temporarily unavailable, and you just can't run it. That's all, right? So you just can't even do ls because um, see it's like you can't even stop it. It keeps telling retry resource temporarily unavailable. I don't do anything. I just tell ls and it dies off. It keeps retrying, and then when you stop, you just stop it off. Yeah, you have to stop all of them, and it still goes on until you stop this, right? You just stop this. This still runs. Thankfully, we stopped it there. The other thing you can do is sudo. Just a minute. Yes. So you just say u limit. 1 minute. You can actually do forkstat. You can also do u limit hyphen a hyphen u hyphen u 1000 or something. Oops. Not this. Um, so this same thing you can actually 1 minute. You can also do sudo vim etc security slash limits dot conf. So if you see this, you'll notice that you know commands for fork bomb. You can actually try out this. So here, what I'm going to do is let's go ahead and change this limit. So here you basically say star, which is for all users. You're going to actually say that we limit the number of um, processes hard, and it's for the number of processes, and we'll just say it's 1000, right? And now if you actually create a new thing, you should see this happening up. You can actually see this 1000, right? So here after every new session you create, only in this session it might not be the same. Every new session that you create, let's say you put bash now, and then you put this, okay, it's still not the same. You'll have to log out, I guess. Create a new session, and then every session will have this limit max. And you should not be able to provide unlimited as the thing. So hyphen u say 2000 something operation not permitted. You have 1000, right? So 2000, nope. 1001, nope. 999 should be possible, I think. And anything more, no. So it's 999, and whenever you create a new tab, you should be able to see that the limit is just 1000. This is coming from the limits that we have defined in etc security limits.conf. Oh, there is a limits.d also. Interesting. I would like to see what is there in that. Nothing. Cool. So this is for all users, I think, except for the root user, right? So if you go to the root user, you will notice that sudo so u limit hyphen a is 32,041, right? So even for the root user, you can change it, by the way. So yeah. So now with this 1000 as the number, let's try out a fork bomb and let's see how that goes, right? So let me run sudo forkstat, right? And then let me run the fork bomb. Cool. So it's running, and that's it. Right. It didn't kill the whole machine. It did run a lot of processes, but I can actually see more and more processes getting created. Let me see if I can actually still access these. And the number of, okay, yeah, I think it has still killed the machine somehow. I'm not sure how. Um, Shell request failed on channel 0. Cool. And here you just can't even do an ls. So here you can see bash, bash, bash getting created. So this is the whole number of processes coming up, right? I think the only thing to do here is either you can stop it and rerun it, or you can destroy it. Some reason, even after setting the limits, I couldn't actually set a limit. Interesting stuff. But I'll probably create one more video where we try to limit this issue. Um, so mitigation is supposed to be this. I just tried that out. For some reason, it still crashes the system instead of stopping at creating 1,000 processes. After that, it should not proliferate. But for some reason, it's still proliferated. I'll probably use C groups and see if that works out. So yeah, for now, that's all I had for this video. I'll see you in the next one. Bye bye.